Hello farriers, I am Jack Roth of Mindanao Forge Company and MFC Horseshoeing Tools. I am bringing this presentation to you today to show you just what all goes into making a pair of hoof nippers here at Mindanao Forge Company. This is how we do it. First, you can see that we are cutting a small piece of steel off of a 3/4 inch diameter joint of H13 steel. We use H13 tool steel for the blades because it is the only steel that will be tough enough to do the job. Those of you who use MFC hoof nippers may have noticed that they tend to last at least half again as long as other nippers, and oftentimes twice as long. Also, the blades stay sharper much longer. We bought this piece of steel in annealed condition. That means 20 Rockwell hardness, because if you forge H13 in an unannealed condition, it will split right up the center of the length of the steel as it cools. Notice the copper coils that we insert the steel into for preheating before we work it. This is called an induction bar heater. The induction bar heater reverses the magnetic polarity of the steel 60 times per second, which makes the molecules try to flip in reverse direction 60 times per second. This is what causes the quick heating. It is much faster than a forge, and an added benefit is that you do not get the scale on the outside of the stock associated with slow heating in a forge. Next, we cut a longer piece of steel, this time not H13. We use 410 stainless to form the body and range of the nipper for 3 reasons. 1. The body of the tool and the range will not rust in your shoeing box. They will remain bright and new looking even after 2 years of use. 2. 410 stainless is an air-cooled stainless tool steel which will air harden sufficiently that the range will not bend or collapse towards each other from the farrier applying pressure to the range to make the cut. And 3, we have found that H13, which is also mildly stainless, is not appropriate to make the joint of the tool because it will often become too hard and break at the rivet hole. But 410 stainless works perfectly for this. We place one end of the 410 stainless steel bar stock into the die to bend it to the proper configuration so that it will fit into the closed dies used to form the shape of the tool. After bending, we draw out the range on an air power hammer. We need to do this for ease in forging, and so there will be no waste. I think you can see that if we formed the tool from the full 3/4 inch diameter thickness of the bar stock, we would have more waste squeezed out of the stock than we have tool. This material is too expensive to allow for any waste. Now we heat the whole piece again, this time in a gas forge to get a heat the full length of the workpiece. We then press it in a closed die system to form the precise shape of the tool. Please notice how little waste steel is pressed out from the workpiece. These are the 2 halves which will make the nipper. Here we are drilling the initial rivet hole for the joint. This is not the final hole, as it will need to be reamed to an extremely precise diameter later. Right after drilling these holes, we use an angle grinder to remove the little bit of excess material which has squeezed out from between the dies. That bit of excess is called flash. You will see shortly how we use a machine bolt to put the 2 halves of the tool together so that the tool is made as a whole instead of 2 separate halves. This is necessary to ensure proper alignment of all of the parts of the tool. All excess material is now ground off, and the tool is beginning to take the appearance of a hoof nipper without the blades. We use an angle grinder with a cutting disc attached to remove 1/2 of the diameter of the stump of the blade. This is done so that when the H13 blade is welded on, we can use a Z-weld for a stronger weld instead of a straight line weld. Otherwise, your nipper blade might break off at the weld, but done in this way, that never happens. We use a TIG welder to weld the blade on. The guy doing the welding should be pretty handy because it takes superb penetration to be sure that the blade will never break off. The next step is to use an angle grinder over the entire tool to bring each and every part of the tool to proper specifications. This is the longest process in making the nipper. It takes 2 to 3 hours per nipper, and the dimensions are checked up and down the length of the nipper against a drawing above the worker's bench to be sure to get the dimensions just right. About now, you can see that our nipper is beginning to look pretty much like a nipper, but we are nowhere near finished yet. We heat the reins and hot stamp our MFC logo and also hot stamp 410/H13 to show that this particular tool is made from stainless steel and H13 tool steel. Then the engraved stamp is filled with hot brazing rod and ground off to give the lettering that nice gold-looking appearance. Now the blades are heat treated by heating the blades to a specific temperature, judged by color in a darkroom. This means that the heat treat is done in a darkroom by our heat treating expert who knows the precise color he needs. After the blade reaches the proper color, it is quenched in oil. This process brings the blades to a Rockwell hardness of around 70 to 75. This is too hard and would cause the blade to be brittle, so it must be tempered. In the film, you can see the operator using a spring punch on the blade. This makes a tiny impression in the blade, which is then measured under a microscope to determine the Rockwell hardness. The tool is then put into the tempering oven, where it is brought slowly up to the proper heat. Held at that heat for several hours, then the oven is turned off overnight so that the tool cools very slowly. This is called tempering, and it brings the Rockwell hardness back down to between 63 and 67, which, in our opinion, is perfect for a nipper blade. In the next scene, it appears that the rivet hole is being re-drilled. Actually, the hole is now being reamed to a very precise diameter to perfectly match the rivets. We have found that to get proper rivets of the proper material and of the perfect diameter, we have to make them ourselves. We make each rivet separately on a shop lathe, and the rivet must perfectly fit into a measuring die that we have made for this purpose. We then insert the rivet into the rivet hole and heat the rivet before peening the rivet. Now, the nipper is ready for finishing and sharpening by our expert tool finishers. All measurements are again checked against specifications. You will notice that the blades of your brand new MFC nipper do not quite touch. There is just a hair's breadth of space between the nipper blades. This is done so that the blades do not impact each other, which would dull them very quickly. The nipper is now polished throughout for a fine finish and checked over once more before going to the quality control officer, who again checks all dimensions to be sure that all parameters are within specifications. The blades are expected to cut a piece of paper completely through without the blades ever touching each other. And last, your new tool is packaged in plastic and then put in our envelope to get ready to ship to you. Altogether, we have about 8 hours invested in each tool. That might seem like a lot of time to make a tool, but it is really not so much time, considering that you will want to get a couple of thousand hours of use from the tool. All of the paired farrier tools we make go through this procedure, or a very similar procedure for a different tool, to try to deliver the best possible tool for you to use.